What we had with ammonia in water, we have a two-stage sort of process. Okay, you have to know both of these reactions to understand what's going on. Now, let's start with water. Water goes through what's called autoionization. And the way to show that, I'm going to use Lewis dot formulas to show that, okay? So here's a water molecule using Lewis dot formulas, all right? Water goes through what's called autoionization, which means it splits up into ions automatically, okay? So what's going to happen is that one of the hydrogens, in this case I'll just choose this one, leaves, but it's not going to take any electrons with it. So let me back up just a little bit and remind you from Unit 2, where we did our electron dot formulas. We gave hydrogen one electron, and oxygen had 6. And then in Unit 3, we showed how we shared those electrons. Okay? And that's how we got to this water molecule, using Lewis dot formulas. We shared electrons. Well, hydrogen brought an electron with it when it joined up with oxygen to make this water. But this hydrogen is going to leave without the electron. Okay? So hydrogen has one proton and one electron. When it leaves without its electron, all that's left is a proton, and protons are positively charged. So when it comes off of there, we've got a hydrogen ion, which is essentially, for all practical purposes, a proton. Okay? And we also have all this stuff that remains. So this oxygen then, and this hydrogen, this structure here, has an extra electron on it. It has one more electron than all the protons that are made up in this oxygen nucleus and this hydrogen nucleus. So the oxygen nucleus, where's my periodic table? Here it is. Well, the oxygen nucleus has 8 protons. The hydrogen nucleus has 1. So we've got a total of 9 protons in this whole structure. But if we were to add up all the electrons, the ones we show here in the valence level and the ones that are below that, we've got 10 electrons in the whole structure. So we're showing 8. Remember, there's 2 electrons in the first primary level we don't show with Lewis dots. So there's 1 more electron than there are protons in this structure. So that overall structure has a negative charge. So that's the first step, understanding how we get to this. Okay? The second step then is actually putting the ammonia in water and having the ammonia then react with this hydrogen ion. Okay? So ammonia is nitrogen with 3 hydrogens and 1 lone pair. And we could go through the whole sharing arrangement to show you how we get there. Now this hydrogen ion, if we put it in water, then there are those hydrogen ions there. Okay? The hydrogen ion, remember, wants 2 electrons. It doesn't have 2 electrons, but it wants 2 electrons. Okay? It had the 2 electrons when it was joined up with the oxygen here, but here, like this, it has no electrons. Well, what it does is, it actually goes up here and covalently bonds with that pair of electrons. So the result is that we get this formula here, where we don't have just 3 hydrogens, we have 4. But this structure had an even number of protons and electrons. This one now has an extra proton on it. So this thing has 1 more proton than all the electrons in there. So it doesn't have a negative charge, it has a positive charge. And we call this ammonium. Okay? So that's the complete explanation, at least at the level we talked about here, about how it is that ammonia forms ammonium in water. Well, it also forms hydroxide in water, because there it is. If these ammonia molecules are taking up these hydrogen ions, then we've got ammonium and hydroxide ions in the water. Does that make sense? Okay? This is positive because this was neutral and we put something that was positive on it. Okay? It's like taking a 0 charge and adding it to a 1 plus charge, and we get a 1 plus charge. Does that make sense? So a neutral compound has a 0 charge. Okay? A particle with a 1 plus charge is a 1 plus charge. If you add those together, then the ending particle has to have a 1 plus charge too. Now here we've got a 0 charge here, but over here we've got a 1 plus charge plus a 1 negative charge. And 0 does equal 1 plus 1 negative, doesn't it? That makes sense? So the math part for the charges works out, and then this is how we put together the chemical compound or the formula. So you got sort of two tracks of thinking going along at the same time. All right? One track of thinking is how we put together the atoms. The other track of thinking is how do we keep up with the charges.